Now that she's back in the atmosphere, with drops of Jupiter in her hair, she acts like summer and walks like rain. Reminds me that there's time to change. Since the return from her stay on the moon, she listens like spring and she talks like June. Train. I'm Mike with List 25, and here are 25 facts about Earth's atmosphere that are truly majestic. 25. Believe it or not, the sky is actually purple. As light enters the atmosphere, air and water particles absorb and re-emit the light, scattering it on its way to our eyes. Since scattering prefers shorter wavelengths, the most commonly scattered color is actually violet. We think we see a blue sky rather than a purple one because our eyes are more sensitive to the color blue. 24. As you likely learned in science class, our atmosphere is made up of about 78% nitrogen, 21% oxygen, and minuscule percentages of argon, carbon dioxide, and other gases. What you might not have learned is that our atmosphere is the only one we have discovered, besides a magnificent find on Comet 67P, which has free oxygen. Since oxygen is a highly reactive gas, it often binds with other chemicals in space. Its pure form on Earth makes the planet habitable, and leads our search for life on other planets. 23. Most people will probably get this question wrong. Is there more water in the clouds or in a clear sky? Though we'd think clouds are the main depository since they drop water, most of the water in our atmosphere is invisible water vapor. For this reason, more sweat lingers on our bodies when the water vapor in the air, known as humidity, is higher. 22. Some global warming skeptics argue it's not a real phenomenon because their city has been getting colder. In fact, Earth's global climate is the combination of a wide variety of regional climates. So, even though some areas are warming while others are cooling, on the whole, the average global climate is rapidly warming. 21. Ever wonder what causes the white streaks seen after some planes shoot through the sky? Those white trails, known as contrails or condensation trails, form when the hot, humid exhaust from an engine mixes with the colder outside air. Water vapor from the exhaust freezes and becomes visible, just like your warm breath on a cold day. A thin and rapidly disappearing contrail means the air at those high altitudes is low in humidity, indicating good weather. A thick, persistent contrail signals high humidity and may mean a storm is coming. 20. Our atmosphere has 5 primary layers which make life possible. The first, the troposphere, extends from sea level to about 11 miles or 17 kilometers up at the equator. Most of our weather happens here due to the mixture of warm air rising and falling to form clouds and wind. 19. The next layer is the stratosphere, reaching up to around 30 miles or 50 kilometers above equatorial sea level. Herein lies the ozone layer, which protects us from dangerous ultraviolet rays. Though it's higher than the troposphere, it can actually be warmer due to the energy absorbed from solar rays. 18. The mesosphere is the middle layer, extending to 52 miles or 85 kilometers above the planet's surface, where temperatures hover around negative 180 degrees Fahrenheit or negative 120 degrees Celsius. Most of the meteors which enter our atmosphere burn up in the mesosphere. 17. Considered the first part of outer space due to its thinness and the area covered, around 430 miles or 690 kilometers above the equator, the ionosphere is where most of our satellites, including the International Space Station, are parked. 16. The exosphere is the 5th and final layer of our atmosphere, which gets weaker and weaker as it extends away from Earth until it merges with interplanetary space. The fascinating part is that this layer can grow and shrink impressively. When the sun is calm and not compressing the layer with its solar storms, the top of the exosphere can extend from its low point of 620 miles, or 1,000 kilometers, all the way up to 6,214 miles, or 10,000 kilometers away from the planet's surface. 15. The trade winds operate in the warmest parts of our planet, between about 23.5 degrees north and 23.5 degrees south. This is why most monsoons and thunderstorms originate in these volatile regions. Just outside of them, at around 30 degrees, there's not much wind. Thus, minimal moisture from the oceans blow inland, and dry air easily sinks to the planet's surface, often resulting in large, arid deserts. 14. Because it's thinner than the first layer, the stratosphere is where most jet planes and weather balloons fly. Jets can fly faster when less restricted by gravity and friction, and weather balloons can get a better view of storms, most of which happen below in the troposphere. 13. Our Earth has likely lost its atmosphere a handful of times. When the planet was covered by magma oceans, massive planet-like interstellar objects smashed into the Earth. These impacts, also responsible for creating our moon, may have been responsible for generating the planet's early attempts at an atmosphere. 12. Without various gases in the atmosphere, the Earth would be too cold for us to exist. Water vapor, carbon dioxide, and other atmospheric gases trap heat from the sun, which radiates off the planet's surface, helping create a habitable climate. Known as the greenhouse effect, scientists are worried that if too many heat-trapping gases enter the atmosphere, this effect will grow out of control and create a scorching, inhospitable environment as seen on Venus. 11. Atmospheric air samples taken after Hurricane Carl passed over Caribbean communities in 2010 revealed that up to 25% of microbes collected were related to or the same as those found in feces. Many of these microbes would have been collected by rain droplets and fallen back down to Earth. Gross. Scientists are looking into these microbes as a possible method of disease transmission. 10. Our notorious and critical ozone layer was created when oxygen atoms were stirred together by ultraviolet light from the sun to bond into trios. These trios of oxygen atoms form the ozone molecules, which prevent the majority of harmful solar radiation from reaching us. Despite its importance, the ozone layer was formed relatively recently, after our oceans had enough life to exhale the amount of oxygen needed to build it. 9. The ionosphere is named as such because highly energetic particles from outer space and our sun help form ions, creating a mild electrical layer around the planet. This layer helped reflect radio waves before satellites were launched. 8. Acid rain, which destroys entire forests and decimates aquatic ecosystems, forms in our atmosphere when sulfur dioxide or nitrogen oxide particles combine with water vapor before raining down. Both of these also occur naturally, with sulfur dioxide being produced by volcanic eruptions and nitrogen oxide coming from lightning strikes. 7. Though air pressure drops as altitude increases, it can vary widely on the same spot of Earth. When the sun heats the ground, it heats the surrounding air, which rises and becomes a low pressure point. Since objects move from areas of high pressure to low pressure, the big H and L signs on a weather report, nearby high pressure air rushes in to equalize the pressure. 6. Lightning is such a powerful force that a single bolt can heat the surrounding air to 54,000 degrees Fahrenheit or 30,000 degrees Celsius. The rapid heating causes an explosive expansion of the nearby air. This boom creates a shockwave that becomes a sound wave we call thunder. 5. Though the wind we feel on the surface often comes from the northern and southern poles, it's actually created around the equator. Since sunlight strikes the planet at the equator and nearby latitudes, most warming takes place here. Some sunlight hits the poles, though it happens at an angle and is less energetic. The heated equatorial air rises high into the atmosphere and moves to the poles, where it sinks and heads back for the equator. 4. The aurora borealis and aurora australis, seen at high northern and southern latitudes, are caused by reactions of ions in the fourth level of our atmosphere, the thermosphere. When highly charged particles from the sun crash into air molecules above our magnetic poles, they glow and create the magnificent light shows viewable from both Earth and space. 3. Skydiver Felix Baumgartner made history when he jumped out of his capsule in the upper layer of the stratosphere. Jumping out at 23 miles or 37 kilometers above the planet's surface, Baumgartner initially free fell in the lower pressured atmospheric level at a rate faster than the speed of sound. As he fell, the air thickened, helping to slow him down. 2. Sunsets often look like they're burning up the sky because small atmospheric particles scatter the light, re-emitting it in orange and yellow hues. The same principle lies behind the formation of rainbows. 1. In 2013, scientists found that tiny microbes are able to survive and thrive many miles above the Earth's surface. Collected from 5 to 10 miles, or 8 to 15 kilometers above the planet, the microbes were found to be partly transient and partly local, breaking down organic chemicals which float in the atmosphere for food. Enjoying our lists? Be sure to click that subscribe button in the top right corner so you don't miss out on new ones every Monday through Friday. Share them with your friends and help us consistently conciliate curiosity. And if you want even more lists, check out these 2 videos here, or just head to our website at list25.com.